Okay, so we're going to talk about the visual pathway. So let's say that you're looking at something in front of you, okay? And what we're looking at is this box here. And what you can see is that on the right side, the box is orange at the top and green at the bottom. And on the left side, it is yellow at the top and blue on the bottom. So this is the original image that you're looking at. Well, as you are looking at something, essentially light is entering into your eye. And that is the stimulus that's picking up all this information. And if you look in front of you, what you can see, what you think of as your peripheral vision, that's your lateral field of vision. And what you would see right in the center, that's your medial field of vision. So the light that you're seeing, which is this image here, basically the lateral field is entering your medial eye, and the nasal field is entering your lateral eye. And that's how they're going in. The first structure that they actually encounter in the eye is the cornea. And at the cornea, the light that you're seeing, it refracts, which means it bends. And what that does is it takes this original image where orange is at the top and green is at the bottom, and yellow is at the top and blue is at the bottom, and it basically turns it, it reverses it. So that instead of orange being on the right, orange is on the left, and yellow is now onto the right. So it's just reversed it. It's turned it back to front. As light continues to go in through the pupil and then it hits the lens, the light will bend again, it refracts again. And what that does is that takes that image, which has been reversed, and it flips it upside down. So that now what you've got is, instead of blue being on the bottom, blue is on the top, and yellow is on the bottom, and green is on the top, and orange is on the bottom. So the image that we originally saw has been reversed and flips upside down, right as light is entering into the eye itself, because light is refracted at the cornea and at the lens. So the image that we saw, if nothing happened to it in the brain, would be upside down and backwards to us. Now, luckily, the brain sorts this out. So what happens is that light from the lateral field, or information from the lateral field, hits the medial eye, and then it travels along the optic nerve. This is the optic nerve. Information from the medial side hits the lateral eye and also travels along the optic nerve. So you have a right optic nerve and you have a left optic nerve because you've got two eyes. And these are what physically jack into the back of the eyeball. These travel in through the brain, but at the optic chiasm, what happens is that your lateral field actually crosses over. So you're getting information from the right lateral field going to the left side of the brain, and the left lateral field is going to the right side of the brain. But the medial field information, it travels ipsilaterally. See that? It's traveling ipsilateral. It does not cross at the optic chiasm. So what that means is that you're forming something, you're going from an optic nerve, and you're forming something called an optic tract. But that optic tract has taken that image and it has reversed it again, because we've got left side lateral field going, or right side lateral field going to the left optic tract, and we've got your left field information going to the right optic tract. So it actually takes that image, so you can see here how we had green and orange on the left and blue and yellow on the right. We've flipped it, we've reversed it. So now it's backwards and back to our original sides. It's just still upside down, but it's back to the colors being on the right side where we would expect them to be. So what this means is that your right optic tract carries all information for your left visual field, because it has your left lateral field and it has your right medial field, whereas this one would have your right lateral field and your left medial field. So information on the right optic tract, it's your left visual field, and on your left optic tract, it is your right visual field. Okay, now the optic tract continues up until it hits the lateral geniculate nucleus of the thalamus. You can put LGN, that's fine, but it is the lateral geniculate nucleus of the thalamus. And at the LGN of the thalamus, it actually forms something called radiations, which is where basically we know that that image, right now it's still upside down, so we need to get it so that we reverse it yet again. So we've got a temporal radiation, and the temporal radiation carries what would be our upper field of vision. And if you think about it, temporal is actually lower in your head. So your upper field of vision is carried physically in a lower aspect of the brain. The parietal radiation carries your lower field of vision. Okay, and again, the parietal is higher, but it's actually carrying a lower field. So these radiations, they travel separately and they end up in the occipital lobe. And you've got the same thing being split here. And what that does is you can see that this image, where we had it reversed so the colors were on the right side, but here we're taking it, we're flipping it again upside down. So orange is back onto the top because it's being carried by the parietal field. The temporal field is here at the bottom. And you've got your, again, yellow and blue. So we've brought the image back up to completely normal, so it now matches. All right, so again, just going through it. So here's going to be the eye, which has the optic nerve plugging into the back of it. And the eye is going to receive information from the lateral field and the medial field. So what's dead in front of your nose, and what's considered peripheral vision. Peripheral vision enters the medial aspect of the eye, and what you would consider as center field is going to hit the lateral aspect of the eye. They travel up together on the optic nerve. So right now, all right side information is carried on the right-hand side. But what happens is at the optic chiasm, your peripheral field crosses over, and your central field stays on the same side. So what I've got now, if you look at this right side, is my left peripheral vision is crossed to the right-hand side, and my right medial side has stayed ipsilateral. So that means that on my right optic tract, I've got my left field of vision. The optic tract will carry up to the lateral geniculate nucleus of thalamus, and there it divides into radiations. And you have a temporal radiation, and you have a parietal radiation. The temporal radiation, they're both carrying the same visual field, they're both carrying the left visual field, but the temporal radiation is carrying the upper field of vision, and the parietal field is carrying the lower field of vision. These both continue up separately until they hit the occipital lobe, and what that does is that basically takes that picture that we were originally looking at, that was turned back to front and upside down, and we are reversing it again and turning it right side up so that we come back to our original image so that the world makes sense to us. Now, if we look at what happens if there's lesions. So this is my right eye, and here's the optic nerve, as you know. So if I did something to either my eye or the nerve, what would happen is I would lose all my right side information, and this is called monocular, mono meaning one, ocular meaning eye, one eye blindness, monocular eye blindness. Now at the optic chiasm, let's say that I put a lesion right here where they cross. Well, what would happen is I would then get tunnel vision because I am losing the lateral field, peripheral vision on each side. And that is called a heteronomous hemianopia because they're meaning they're the opposite half side, which is the hemi. A is absent, opia is vision. But if you think of it as tunnel vision, that's probably an easier way to think of it. Here at the optic tracts, which are formed after the optic chiasm, remember that the right side of the brain is carrying left visual field. So if I had a problem with my right optic tract, I would lose my full left visual field and I wouldn't be able to see that. Okay, and the same thing, if I lost my left optic tract, I would lose my right full visual field, upper and lower quadrants both. At the lateral geniculate nucleus of the thalamus, I split into my radiations. I've got a temporal and a parietal radiation. If I had a lesion to my temporal radiation, we know that the right side is carrying, of the brain is carrying left visual field information. But this is just carrying one half of it. This is carrying my upper field. So I would have a loss of a quadrant, and it would be my left upper quadrant. And in the parietal field, again, it's only carrying half of the information, so I would lose a quadrant, but it would be my lower left visual field that I would lose instead. If something happened up here in the occipital lobe, then I would have monocular blindness, and that can come as different things. So it depends. Remember, you have a left and a right occipital lobe, so that could be that you had full visual loss. It could be that you had enlargement of a blind spot, but what I want you guys to remember is just cortical blindness. The eye is physically working, but the brain refuses to pick up the information, so the problem is up at the receiving end rather than anywhere else. Okay, I hope this helps. Have a great day.